Good morning, student. Today we'll start chapter 2, acids, bases and salts. Now, acids and bases. The word acid came from Latin word acidus or acere, which means sour. Sour taste is the most common characteristics of acid. There are many substances which contain acids and hence taste sour, such as curd, grapes, tamarind, lemon, tomato, etc. Right? And on the other hand, bases are bitter in taste and feel soapy on touch. There are many substances which contain base such as soap, detergent, whitewash, that is calcium hydroxide. They all contain bases. Now here are some examples of acids. Hydrochloric acid made up of hydrogen ion and chloride ion. Sulfuric acid made up of hydrogen ion and sulfate ion. Nitric acid made up of hydrogen ion and nitrate ion. Now these all are said to be acids. Now what is common in them? If you see this one, H ion, chloride ion, here H ion, sulfate ion, here H ion, nitrate ion. So all the negative ions are different but positive ions are same, that is hydrogen ion. So what is common in acids? Hydrogen ion. Right? Now acids, when dissolved in water, they dissociate to give hydrogen ion or hydronium ion. Let's take this example. Hydrochloric acid, when water is added to it, it forms hydronium ion, H3O+. This is hydronium ion along with chloride ion. Let's understand how this hydronium ion is formed. This equation we can write in two steps. Hydrochloric acid, when dissolved in water, releases hydrogen ion along with chloride ion. Now this hydrogen ion cannot exist alone. So this hydrogen ion combines with water molecule to form this hydronium ion, that is H3O+. So whenever an acid is dissolved in water, this hydronium ion is formed along with the negative ion. Now hydronium ions are also said to be hydrated, or they are called as hydrated hydrogen ion. Now hydrated word is related to water. So when water is added to hydrogen ion, it is said to be hydrated hydrogen ion. So you can see here water is added to hydrogen ion, so it forms hydronium ion, which is also called as hydrated hydrogen ion. So all the acids, whether it's hydrochloric acid, nitric acid, sulfuric acid, they all will dissolve in water and will form hydrogen ion as positive ion, which will further combine with water molecule to form hydronium ion. So remember now, all those substances are said to be acids which dissolve in water to form hydrogen ion or hydronium ion as only positively charged ion. Now bases. Bases are generally oxides, right? Bases are generally oxides of or hydroxides of metal. Now here sodium hydroxide, potassium hydroxide, calcium hydroxide. Now you can see what is common in all these hydroxide. See, sodium is a metal. Along with metal there is OH ion. Metals are positive, so OH ions are negative out here. Here potassium, this is positive, this is negative OH ion, this is again positive, and this hydroxide is negative. Now they also, when dissolved in water, they release hydroxide ions as negatively charged ion. So NaOH, if you dissolve in water, aqueous means when you dissolve in water, so you get sodium ion along with that OH ion. So bases are those substances which when dissolved in water release hydroxide ions as negatively charged ions. Now what is common in acids and bases? Acids, they release hydrogen ion when dissolved in water. Bases, they release hydroxide ion. So both acids and bases, when they dissolve in water, they can conduct electricity because of the presence of ion. So if we take a solution of hydrochloric acid and allow the current to pass through it, the current will easily pass because of the presence of hydrogen ion and chloride ion. Similarly, if we take solution of sodium hydroxide, this will also conduct electricity because of the presence of sodium ion and hydro ions. Types of acids. Acids can be divided into two types on the basis of their source, that is, from where they are obtained. Mineral acids, acids that are prepared from minerals that we get in the earth crust, and they are known as mineral acids, or we also call them as inorganic acids, man-made acids, or synthetic acids. Example: hydrochloric acid, sulfuric acid, nitric acid, carbonic acids. So these are some examples of mineral. Now, on the basis of sources, the second category is organic acids. Acids which are obtained from natural sources, that is plants and animal. See, organic word comes from organism, right? So plants and animals, the acids that we get from these sources, they are said to be natural acid or organic acids. Commonly found organic acids are citric acid, we find them in orange and lemon, tartaric acid in tamarinds, lactic acid in curd, oxalic acid we get in tomatoes, acetic acid is in ketchup, in vinegar, formic acid, methanoic acid also we call it, it is present in ant sting, in nettle leaf sting. So these are the organic acids that we get from plants and animals. Acids can be divided on the basis of strength. Now what is strength? Strength out here means that the number of hydrogen ion that an acid can produce when it is dissolved in water. So on basis of that, acids are said to be strong or weak. So strong acids are those acids which completely ionizes in water to produce large number of hydrogen ion. Example: hydrochloric acid, sulfuric acid, nitric acid, hydrobromic acid. These all acids are said to be strong acid. If you see here in the picture, here these are the acid molecules, right? Now when they are added into water or when they are dissolved in water, these acids, they form ions. You can see all the molecules, they have changed into ions. So number of ions are produced, large number of ions are produced. So it is said to be strong acid. While on the other hand, weak acid ionizes partially in water to produce small number of hydrogen ion. Example are carbonic acid, phosphoric acid, acetic acid. These all are said to be weak acid. In all your organic acids are weak acids. So here if you see these molecules, so when water is added into it, only few of them ionize, rest stay in the molecular form. So they are said to be weak acids. Acids are divided on the basis of amount of water. Again, two categories: concentrated acid. Concentrated acids have large amount of acid dissolved in less amount of water, right? For example, concentrated hydrochloric acid will have more HCl and less water. So solute will be more and solvent water will be less. While in dilute acids, small amount of acid is dissolved in large amount of water, right? So solute is less and solvent water is more. So dilute hydrochloric acid have less amount of HCl and more amount of water. Now one thing to remember, whether a strong acid is dilute or concentrated, it is going to remain strong, because strong acid is said to be a strong on the basis of hydrogen ion that it produces. So whether water is less or water is more, it doesn't matter, it will produce more amount of or large amount of hydrogen ion. But a weak acid, whether it is concentrated or dilute, it is going to be weak only, right? So it doesn't matter whether it has more water or less water, it will produce less hydrogen ions only. So strong acid remains strong in concentrated or dilute form, and a weak acid remains weak in concentrated or dilute form. Now bases are also of two types. Strong bases that ionizes completely in water to produce large number of OH ions. So strong base ionize fully in water to produce large number of OH ions. Example: sodium hydroxide, NaOH, potassium hydroxide, lithium hydroxide, calcium hydroxide. And all these strong bases are also known as alkali, right? So all bases that produce large number of OH ions are known as alkali. Weak bases ionize partially in water to produce small number of OH ions. For example, magnesium hydroxide, ammonium hydroxide, copper hydroxide, and they are simply called as base. All alkalis are bases, but all bases are not alkali. Children, remember this. These all are bases because they produce OH ions when dissolved in water. But since they produce large number of OH ions, so these bases are known as alkalis. While this one, magnesium, ammonium, they also produce OH ion but less number. So all substances or all bases that release less number of OH ion, they are just called bases. So all alkalis are bases, but all bases are not alkalis. Diluting acids and bases. Children, you can dilute a given acid or a base by adding more amount of water into it. But while you are diluting acid, it is recommended that acid should be added to water and not water to acid, because the process of dissolving an acid or a base in water is highly exothermic. Exothermic means large amount of heat is given out. So this method, that is in which if you take a container, in the container you take acid or a base and you add water into it, this is wrong method. Because if water is added to acid, then heat generated may cause the mixture to splash out and cause burns, and the glass container may also break due to excessive local heat or the heat that is given out. So this is very wrong method to dilute acid or a base, because the mixture will splash out or the glass container may break. So if you have to dilute acid, then take water in a container and slowly add acid or a base, because then water here will absorb the excess heat that is being generated when acid or a base is being added to water. So this is the correct method of diluting acid or a base. Now when acid or a base is mixed with water or more amount of water is added to it, then there is decrease of concentration of hydrogen ion or hydronium ion if it's an acid, and if it's a base, then there will be decrease of OH ions per unit volume, right? That means the number is not going to reduce, but per unit volume it will decrease, because now more water is being added to it. So such process is called as dilution. Children, we know now that acids are those substances which when dissolved in water produces hydrogen ion or hydronium ion as positively charged ion, while bases are those substances that produce hydroxide ions when dissolved in water. Now, whether a substance is acid or a base, we can identify with the help of indicators. So indicators are those substances which indicate acidic or basic nature of substance by color change. There are different kind of indicators. Here we'll be discussing about acid-base indicators. So acid-base indicator tell us the nature of substance, whether it is acidic or basic. Now different type of acid-base indicators are natural indicators. They are obtained from natural sources. For example, Litmus, it is obtained from lichen. It is purple in color. Then red cabbage, turmeric, China rose. These all are obtained from natural sources. So they are said to be natural indicators. Synthetic indicators, they are synthesized in laboratory. Phenopthalein, methyl orange, these are the example of synthetic indicators. Now olfactory indicators, olfactory is sense of smell. Substances that change the smell when mixed with acid or base. So there are certain substances like onion, vanilla, clove oil. These all are the substances whose smell varies depending on whether they are added to acidic or basic substance. Now here are certain indicators and the effect on acids and bases. First one, red litmus. The original color is red and when it is added to acid there is no change, while when it is added to base it turns blue. Blue litmus, original color is blue. When added to acid it changes its color to red and when added to base no change. Turmeric, the original color is yellow but when added to acid there is no change and when added to base it becomes reddish brown. Red cabbage, the original color is purple. When added to acid it becomes reddish in color and when added to base it becomes greenish yellow. Phenopthalein, its original color is colorless. When added to acid it is colorless. When added to base it becomes pink. Methyl orange, its original color is orange. When added to acid it becomes red and when added to base it becomes yellow. While onion, in acidic no change is there but when added to base its smell vanishes. Vanilla also, in acid there is no change but when added to base its smell vanishes.